Hey everyone, welcome back to another video from my channel. In our last video, we learned about the quartiles and the interquartile range and how we can calculate them using discrete data values. Today, we will be expanding on that idea for continuous data. When data are presented in a grouped frequency table, you can use a technique called interpolation to estimate the median, quartiles, and percentiles. When you use interpolation, you are assuming that the data values are evenly distributed within each class. To demonstrate how interpolation works, let us do an example math. From number 3 in the S1 book, a hotel is worried about the reliability of its lift. It keeps a weekly record of the number of times it breaks down over a period of 26 weeks. The data collected are summarized in the table opposite. Use interpolation to estimate the median number of breakdowns. So here we have the table here containing the number of breakdowns and their corresponding frequencies. Now, if you look at the table, you can see that the number of breakdowns are not connected and they are in a range. So first we have to connect them or correct them, just like we did in our last video. So tabulating this vertically, we can say that this is going to be the number of breakdowns n and their corresponding frequency as f. So this is going to be 0 to 1.5, because if we remember from our last video, we usually subtract 0.5 with the last or the smallest endpoint of the class boundary, and we add 0.5 with the highest class boundary. But because this is already 0 and we know that the number of breakdowns cannot be negative, therefore it will stay as 0 here. For the next one, however, this will be 1.5 because 0.5 plus 1 is 1.5, and 2 will be subtracted with 0.5, so 2 minus 0.5 will be 1.5, and you can notice that this is now connected, so this will be 1.5, and 3 will be added with 0.5 to be 3.5. Similarly for 4, we can subtract that with 0.5 to get 3.5, and then add 5 with 0.5 to get 5.5. And this is our corrected class boundaries. So this is going to be 8 and 7 and 1. This is our completed table. Now what we have to do is we have to write down the cumulative frequency just like how we did for the median, and we have to find out where the median lies. So cumulative frequency for the first one will be 18, then it will be 18 plus 7, adding this one, so this is going to be 25. Then we have 25 plus 1, which gives us 26. And so the cumulative frequencies are going to be 18, 25, and 26. Now, because we know that the median must lie at 50% of the data, so it should be the 50% of 26, so 26 divided by 2, which is going to be 13. Now let us look at where 13 exists. So the 13th term or the 13th breakdown will be before 18, so therefore the median class will be 0 to 1.5. And now to apply the interpolation formula, what we have to do is we have to draw a straight line like this, and then you have to place the class boundaries from lowest to highest, so 0 and 1.5 will be the endpoints, and their corresponding frequencies will be 0 here, because at 0 number of breakdowns there will be a 0 frequency because the class ends at 18. Now let us place Q2 or the median, which is unknown, and its corresponding frequency should be 13 because we have found that here. Now using interpolation, we can say that the median Q2 minus the end class boundary divided by 1.5 minus the end class boundary again. So Q2 minus 0, which is the last boundary, divided by 1.5, which is the highest boundary, minus the lowest boundary, should be equals to the ratio of the corresponding frequencies. So 13 minus 0 divided by 18 minus 0, because the corresponding frequency for Q2 is 13, as you can see here, and the corresponding frequency for the class boundary 0 is also 0. Then for the class boundary 1.5, the corresponding frequency is 18 here, and then subtract it with 0. So we can find Q2 being equals to 1.5 multiplied with 13 divided by 18, which gives us approximately 1.08 number of breakdowns. And this is our answer. Moving on for number 5. A roadside assistance company kept a record over a week of the amount of time in minutes people were kept waiting for assistance. The times are shown below. So we have time waiting in T minutes and their corresponding frequencies. So for number A, we have to find the mean time spent waiting. So for the first one, we can tabulate the data here. This will be time, which is ranged and continuous. So 20 to 30, and then 30 to 40. Similarly, we have 40 to 50, 50 to 60, and then finally 60 to 70. And if you notice, all of them are connected to each other. For example, the highest class boundary of the previous one is equals to the lowest class boundary of the next one. And their corresponding frequencies are 6, 10, 18, 13, and 2. Now we can find the midpoint, which is x, being 25 here, 35, 45, 55, 65. We have used the formula here. X is equals to midpoint for A and B, which is going to be A plus B divided by 2. So we can calculate the corresponding values of XF, or the product of the midpoint and their corresponding frequency. So this is going to be 150, then 350, 810, 715, and then 130. We can calculate the summation of XF being 255 by adding all of them. And similarly, the summation of F will be 49 by adding all of the frequencies. And therefore, the mean will be summation of XF divided by summation of F, which is 2155 divided by 49, which is approximately 44.0 minutes to 3 significant figures. Now for number B, we have to calculate the 65th percentile. So let's find out where it lies first. So P65, or the 65th percentile, must lie at the 65% of the whole data. And we know that the whole data is going to be 49 because it is comprised of 49 unique data values. So multiplying with 49 gives us a value of 31.85, meaning that the 65th percentile is the 31.85 term. So drawing a straight line just like before, we're going to place P65 here and its corresponding frequency at 31.85. Now let's find out in which class does this belong to. So in order to do that, we have to figure out the cumulative frequency. So therefore we can tabulate this again by writing C. So for the first one, this is going to be 6. The next one is going to be 10 plus 6, which is 16. Then 16 plus 18, which is 34. Then 47. And then at the end, we have 49. And if you notice, the summation of F is exactly the same as the end value of CF, or the cumulative frequency. Now 31.85 lies before 34, meaning that the 65th percentile must lie within this class. So the endpoints are 40 and 50 here. And their corresponding frequencies will be the cumulative frequency of 40 here, which is 16 here. And then for the last one, this is going to be 34. Now we can use the formula again. P65 minus 40 divided by 50 minus 40 must be equals to their corresponding frequency ratios. So the frequency for P65 was 31.85, subtracted with 16, and then for the class boundary of 50, this is 34 and subtracted with 16. So we can find P65 being equals to 40 plus 10 multiplied with 317 divided by 360, and this gives us an answer of 48.8 minutes. For number C, the firm writes the following statement for an advertisement. Only 10% of our customers have to wait longer than 56 minutes. By calculating a suitable percentile, comment on the validity of this claim. The first thing that might come to your mind is to calculate P10 or the 10th percentile. But if you look at the data, the 10th percentile will be around here. So we cannot use that because that does not give us the accurate value. Rather, what we have to do is we have to calculate the value of P90 or see where P90 lies, because that will be the 90th percentile and the rest of the values will be 10%. And this is what we have to find. So we can find out the frequency for P90 or the 90th percentile, which should be at the 90% of the total values of the total data. So the total frequency was, so calculating this gives us 44.1, meaning that the 90th percentile is the 44.1 term. So using the cumulative frequency table, we can see that 44.1 lies right after 47, meaning that the P90 must lie within this class, which is 50 to 60. So we can draw a straight line again, writing the endpoints as 50 and 60 and their corresponding frequencies, or rather cumulative frequencies. So for 60, the cumulative frequency was 47, as you can see here. And for 50, it was 34, which is the endpoint of the previous class. And P90 lies here with a corresponding frequency of 44.1. Now using linear interpolation again, P90 minus the endpoint or the end class boundary divided by 60, the highest class boundary, subtracted with 50 again, is going to be equals to their corresponding frequency ratios. So 44.1 minus 34 divided by 47 minus 34, and evaluating this gives us a value of P90 being 57.8 minutes. Now what it means is that if we have a total data of 100%, the 90th percentile is 57.8 minutes. And what it means is that only 10% of the total customers have to wait for a time longer than 57.8 minutes. So the statement was it was longer than 56 minutes, but in actuality what we found was 57.8. So this means that the claim is not valid. So claim is false. Moving on, a measure of spread is a measure of how spread out the data are. Here are two simple measures of spread. The range is the difference between the largest and smallest values in the dataset. The interquartile range, something that we already have discussed in our previous video, is the difference between the upper quartile and the lower quartile, or Q3 minus Q1. The range takes into account all of the data but can be affected by extreme values, meaning a very large value or a very small value compared to the rest of the data. The interquartile range is not affected by extreme values but only considers the spread of the middle 50% of the data. The interpercentile range is the difference between the values for two given percentiles. The 10th to 90th interpercentile range is often used since it is not affected by extreme values but still considers 80% of the data in its calculations. So for the last math, the lengths of a number of slow worms were measured to the nearest millimeters. The results are shown in the table. For number A, we have to work out how many slow worms were measured. So to find that, we have to find the summation of F, which is going to be the addition of all of them. So 4 plus 4 plus 2 plus 7 plus 20 plus 24 plus 10. And this gives us a value of 71. For number B, we have to estimate the interquartile range for the lengths of the slow worms. So we have to make a vertical table here, and we have to connect or correct the endpoints here because they are not connected, as you can see. So we can write down the cumulative frequency first because it's easier. So this is 4, then this is 8, 10, 17, 37, then we have 61, 71, and we can now write the corrected values, which is going to be 124.5 to 139.5, because if you remember, we subtract the lowest boundary with 0.5 and we add 0.5 with the highest boundary. So the next ones will be 139.5 to 154.5. Then we have 154.5 to 169.5. Similarly, we have 169.5 to 184.5. Then 184.5 to 199.5. Similarly, 199.5 to 214.5. And finally, 214.5 to 229.5. And this is a corrected class boundaries. So you can find the midpoint, which is by adding the two endpoints or the class boundaries and then dividing by 2. So we get 132, 147, 162, 177, 192, 207, and then finally 222. Now we can calculate the products of a midpoint with the corresponding frequency, XF, which is going to be 528, 588, and 324, 1239, 3840, 4968, and then finally 2220. We can find the summation of XF being 13707, and the summation of F was 71. So this was to find the mean, which is for number C. But for number B, we have to find the interquartile range. So we have to find the upper quartile and then the lower quartile. So in order to find the quartiles, for the lower quartile, we know that it lies at 1/4 of the total data. So 1/4 multiplied with the summation of F, which is going to be 71. So this gives us a value of 17.75, meaning that the lower quartile lies at the 17.75 position. So we can use the table for the cumulative frequency and see that 17.75 is right after 17, meaning that the Q1 must lie within this range or within this class. Therefore, we can construct a straight line and then we'll place Q1 here, which is the unknown variable. At the end, this will be the lowest boundary, which is 184.5. Do note that we are still using the corrected boundary. And for the highest boundary, this is going to be 199.5. We have a value of 17 because the cumulative frequency for 185 ends at 17. For Q1, this is going to be 17.75. And for the higher boundary one, this ends at a cumulative frequency of 37. So we can use the linear interpolation technique. Q1 minus the lowest boundary, which is 184.5, divided by the highest boundary, 199.5, subtracted with 184.5, being equals to 17.75 minus 17, divided by 37 minus 17, which is the ratio of their corresponding frequencies. So solving for Q1, we can get a value of 185.0625. This is the lower quartile, which has a unit of millimeters. And for the upper quartile, we know that it lies at 3/4 of the data. So 3/4 multiplied with the summation of f, or the total frequency, which is going to be 53.25, meaning that the upper quartile is at the position of 53.25. So taking the cumulative frequency from the table, we can see that 53.25 is right before 61 and after 37. So that means that the upper quartile must lie within this class 200 to 214, and we will use the corrected one. Lower boundary is going to be 199.5, and the upper boundary is going to be 214.5 just from the table. Then we have Q3 here, which is unknown, but its corresponding cumulative frequency is going to be 53.25. For the upper one, this is going to be 61, and for the lower one is going to be 37. If you see from the table here, 61 is a cumulative frequency for 214.5, and for 199.5 this is going to be 37. So continuing just like before, Q3 minus 199.5 divided by 214.5 minus 199.5 is going to be equals to the ratios of their frequencies. So 53.25 minus 37 divided by 61 minus 37. Therefore, Q3 on the upper quartile is going to be 209.65625, and this is the upper quartile. Therefore, the interquartile range, or IQR, is going to be the subtraction of these two, or the difference. So Q3 minus Q1, which gives us a value of 24.59 or 24.6 millimeters to three significant figures. For number C, we have to calculate an estimate for the mean length. So we have already done all of the mathematics here by calculating summation of xf, x, and their corresponding multiplication or product, xf. So the mean is going to be summation of xf divided by summation of f. So 13707 divided by 71, which gives us an approximate value of 193.1 millimeters. For number D, we have to estimate the number of slow worms whose length is more than one interquartile range above the mean. So what it means is that we have to find the value of this length, and then using interpolation and from the cumulative frequency table, we have to find out how many have that specific length and then subtract it with the total length. So let us first find out the value, which is going to be 1 IQR above the mean. So 1 IQR plus the mean, which has a value of 24.6 plus 193.1, which is 217.7 millimeters. Now using the table here, we can say that 217.7 millimeters is within this range of lengths. So therefore, using linear interpolation and drawing a straight line, this is going to be 217.7. The end boundary is going to be 214.5. The last one is going to be 229.5. Therefore, their corresponding frequencies or cumulative frequencies were, for 214.5 it was 61 here, because as you can see this ended with 61. So this is 61, and for the last one this is going to be 71. And for the IQR plus mean, this is going to be x. So we can use linear interpolation, x minus 61 divided by 71 minus 61 being equals to their ratios of lengths. So 217.7 minus 214.5 divided by 229.5 minus 214.5, and this gives us a value for x, which is going to be 63.03 worms. What this means is that 16.03 worms have a length of 217.7 millimeters or less, because this is the critical point at which all of them are present. And what it basically means is that this is not the answer, as we have to find the number of slow worms whose length is more than this value. So therefore, the number of worms with a length greater than this required value is going to be the total number of worms, 71 minus 63.03, which gives us a value of 7.97 worms. Now, if you think about it realistically, worms cannot exist as a fraction or a decimal. So realistically, what it means is that only 7 worms have a length of 1 interquartile range above the mean. And this is our final answer. Thank you all for watching. Make sure to leave a like, comment, share, and subscribe if you enjoyed my content. See you guys in the next video. Goodbye.